Hello, welcome to the Sleepy Archive. This is a quiet place where knowledge is stored gently, without urgency, and without expectation. You don't need to remember anything you hear. You don't need to stay awake. If your thoughts wander, or your breathing slows, that's perfectly fine. Tonight, we'll explore what it means to exist beyond Earth. Not dramatically, not heroically, but calmly. We'll move slowly through quiet facts about space, the human body, and the fragile systems that keep life intact when the planet is no longer beneath our feet. Let the words pass by like distant lights. You can listen or simply rest. Space is often described as empty, but emptiness is not the same as nothing. Even in the vast distances between stars, there are particles, fields, and radiation moving silently through the dark. Atoms drift alone for years without collision. Light travels uninterrupted, crossing distances that have no scale in human terms. To humans, space feels like absence, but to the universe, it is a quiet medium, filled just enough to matter. In space, nothing presses back, and that absence of pressure is one of the most powerful forces an astronaut must face. The human body is built to exist under pressure. The pressure of air, the weight of gravity, the steady push of an atmosphere holding everything in place. When that pressure disappears, the body does not panic, but it does begin to change immediately. Gases expand. Oxygen leaves the bloodstream. Liquids behave differently, even at normal temperatures. This is why a spacesuit is not clothing. It is a small, artificial world. Inside it, pressure is carefully maintained, layer by layer, so the body can continue doing what it has always done without noticing how close it is to nothing at all. A spacecraft is not a fortress. It is a sealed container. Thin walls separate breathable air from a vacuum that pulls constantly, patiently, without sound. A tiny fracture, smaller than a grain of sand, can allow air to escape. Not violently, not dramatically, just steadily. Engineers design multiple layers, alarms, and redundancies. But the reality remains the same. In space, life exists because a surface remains unbroken. Sound does not travel through empty space. There is no air to carry it. A shout outside a spacecraft would not echo. It would not fade. It would not exist at all. And yet, space is not silent. Inside spacecraft, vibrations move through metal. Machinery hums. Panels creak as temperatures shift. Astronauts hear life through structure, not air. The most constant sound is often their own breathing, measured, steady, and reassuring. In space, sound becomes personal. It belongs only to what is connected. On Earth, direction is effortless. Down is always waiting. In orbit, direction disappears. There is no floor pulling at the body, no ceiling pushing back. Astronauts learn to think in reference points, not gravity. A handhold becomes a wall. A panel becomes a ceiling. Movement becomes intentional. Even rest requires adjustment. The body must be secured so it does not drift. In space, stillness is not natural. It must be created. Sleeping in space does not involve lying down. There is nowhere to lie. Astronauts secure themselves inside small sleeping compartments, often no larger than a closet. A sleeping bag keeps the body from drifting. Straps keep arms from floating upward. Some astronauts miss the feeling of weight. Others find floating restful. The brain adapts slowly. Dreams remain familiar, but the body no longer sinks into anything. In orbit, sleep becomes a pause in motion, not a descent. Space travel is a psychological experience as much as a physical one. Days are structured, routines are precise, but isolation is constant. Earth becomes distant. Communication carries delay. Privacy is limited. Astronauts train for this long before launch. They practice calm. They practice patience. They practice being alone with their thoughts. In space, emotional stability is a form of survival. The mind must remain steady in an environment that offers no comfort on its own. Even emotions behave differently in orbit. Tears do not fall. They gather. They cling to the eyes, forming small spheres that refuse to leave. Astronauts learn to wipe them carefully before they drift into equipment or blur vision. Crying still brings relief, but it requires adaptation. In space, even vulnerability must be managed gently. Earth is wrapped in protection, a magnetic field, a thick atmosphere. In space, that protection fades. Radiation passes through silently. It cannot be felt. It cannot be seen. Long exposure damages cells, weakens bones, alters DNA. Spacecraft include shielding, but shielding adds weight, and weight limits travel. Every mission is a balance between distance and safety. In space, danger is often invisible, measured quietly over time. The moon has no weather. No wind, no rain, almost no erosion. The footprints left by astronauts decades ago remain unchanged. They may last millions of years. These marks are not monuments. They are simple impressions in dust. But they tell a story, not of conquest, but of brief presence. Humans arrived, stood, and left, and the surface remembered. Spacecraft windows are thick, layered, and reinforced. Still, they are struck by tiny particles traveling faster than bullets. Each impact leaves a mark, a small scar. Over time, windows are replaced, rotated away from risk, carefully monitored. Looking out at Earth is one of the greatest privileges of spaceflight. And each scratch is a reminder of what exists beyond the glass. From orbit, borders disappear. Oceans connect continents. Lights form networks, not nations. Sunrise arrives every 90 minutes. Night follows just as quickly. Astronauts often describe a shift in perception, a quiet realization. Earth is not divided, it is shared. This perspective does not fade easily. Many carry it home with them. Once seen, it changes how the planet feels forever. The Sleepy Archive does not rush conclusions. It simply stores what is known and allows it to rest. Life beyond Earth is fragile, carefully maintained, quietly resilient. Whether you stayed awake for every word or drifted somewhere along the way, the archive remains. Knowledge does not demand attention. It waits. If you return another time, this place will still be here. Until then, rest. The human body is designed to respond to resistance. Every movement on Earth meets gravity. Every step, every breath, every posture is shaped by weight. In orbit, that resistance disappears. Muscles no longer work to hold the body upright. Bones no longer bear load. Even the heart pumps under different conditions. The body does not fail. It adapts. But adaptation comes with change, and change must be carefully observed. In space, the body begins a quiet conversation with an environment it was never meant to inhabit. On Earth, bones constantly rebuild themselves. Cells break down old material. New material takes its place. This process depends on stress. Walking, standing, and lifting tell bones they are needed. In microgravity, that message fades. Without weight pressing through the skeleton, bones begin to lose density. Calcium slowly leaves. Structure weakens. Astronauts can lose bone mass at a rate similar to severe osteoporosis. To slow this, they exercise for hours each day, using resistance machines designed to mimic gravity. Even so, the body remembers where it is. In space, strength must be actively preserved, or it quietly dissolves. Muscles exist to move against something. In orbit, there is very little to push against. Leg muscles weaken first. Back muscles follow. Postural muscles, once essential, become optional. Exercise becomes non-negotiable. Treadmills use harnesses to pull astronauts downward. Weights are replaced with vacuum resistance. The goal is not fitness. It is preservation. Without constant effort, the body optimizes itself for stillness. In space, movement must be intentional, or the body forgets why it ever learned to move at all. On Earth, gravity pulls blood downward. The heart works against that pull. In space, blood redistributes. Fluids drift upward, toward the chest and head. Faces appear fuller. Legs thin slightly. Sinuses feel congested. The body interprets this shift as excess fluid. It responds by reducing blood volume. Over time, the heart becomes slightly smaller, adjusted to an easier task. When astronauts return to Earth, gravity returns suddenly. Blood falls, pressure drops. Standing up becomes difficult. The body must relearn what down feels like. Some astronauts experience changes in vision during long missions. The upward shift of fluids can alter pressure inside the skull. This pressure gently reshapes the eyes. Vision blurs. Focus changes. For most, the effect is mild. For some, it lingers. Doctors monitor this carefully, studying how pressure, posture, and time interact. The eyes evolved to look out from a planet that pulls everything downward. In orbit, even sight must adapt to a new balance. The immune system is deeply tied to environment. In space, immune responses can change. Some cells become less active. Others behave unpredictably. Old viruses that lie dormant in the body can reactivate under stress. At the same time, bacteria adapt quickly to microgravity, sometimes becoming more resistant. This is why cleanliness matters so much in orbit. Why air filters hum constantly. Why surfaces are wiped again and again. In space, the boundary between body and environment is thinner than it appears. Humans are not alone in their bodies. Trillions of microorganisms live on the skin, in the gut, and throughout the respiratory system. When astronauts go to space, their microbiomes go with them. Some bacteria grow faster in microgravity. Others change behavior. Scientists study these shifts carefully, not just for astronaut health, but to understand how life responds to new worlds. The presence of microbes raises larger questions. If life can survive launch, radiation, and vacuum, could it travel between planets? In space, even the smallest life forms become messengers of possibility. Time in space is measured precisely. Clocks remain accurate. Schedules remain strict. And yet, time feels different. Days are marked by routine, not sunrise. Nights arrive without darkness. The body's internal clock struggles. Sleep cycles drift. Astronauts rely on artificial lighting to signal day and night. Despite this, many describe time as flattening. Moments blend. Weeks pass quietly. In space, time becomes something you manage consciously, rather than something that carries you forward. Exercise in space is not optional. It is a medical requirement. Astronauts exercise for up to 2 hours a day, every day. They strap themselves to machines. They pull against resistance. They run without moving forward. This routine is not about performance. It is about return. The goal is to come back to Earth able to stand, walk, and live normally. In space, exercise becomes a reminder of gravity, a rehearsal for a world waiting below. Food behaves differently without gravity. Liquids form floating spheres. Crumbs drift. Meals are carefully designed. Textures are controlled. Packaging is functional. Taste can dull slightly in orbit, partly due to fluid shifts in the head. Astronauts favor stronger flavors. Spices matter more. Eating becomes less about pleasure and more about routine. Still, shared meals remain important. In space, food is one of the few rituals that still feels human. There are no showers in orbit. Water does not fall. It floats. Instead, astronauts clean themselves with damp cloths, rinseless soap, and careful movements. Hair is washed with minimal water and vacuumed dry. Clothing is worn longer than on Earth, designed to resist odor and bacteria. Hygiene becomes deliberate, slow, methodical. In space, cleanliness is not comfort. It is maintenance. Spacecraft are small. Walls are close. Privacy exists in fragments. A sleeping compartment. A moment with headphones. Every movement is shared. Every sound travels through structure. Astronauts train for this. They learn communication skills, conflict resolution, and emotional regulation. Small tensions are addressed early. Silence is respected. In space, cooperation is not optional. It is part of the life support system. Even without gravity, emotions remain heavy. Awe, loneliness, responsibility. Seeing Earth from orbit can intensify feelings rather than soothe them. Astronauts describe a sense of guardianship, a realization of fragility. Psychological support continues throughout missions. Conversations are encouraged. Reflection is guided. In space, mental health is not secondary. It is essential. No matter how long a mission lasts, the body remembers gravity. It remembers weight, resistance, down. When astronauts return, their bodies must relearn familiar forces. Standing feels strange. Walking requires effort. Balance wavers. Recovery takes time. Space does not replace Earth. It temporarily suspends it. The body, patiently, waits to return. The human body can adapt to space, but it cannot do so alone. Every breath, every heartbeat, every stable moment depends on machines working quietly in the background. In the next part of the archive, we'll turn our attention to those systems. The ones that recycle air, purify water, manage heat, and keep life intact inside a fragile shell drifting through vacuum. It is an environment. On Earth, life is supported automatically. Air surrounds us. Water flows. Temperature balances itself. In space, none of that exists. A spacecraft is not simply a way to travel. It is a manufactured pocket of Earth, built piece by piece. Every system inside it exists to replace something nature once provided freely. Air must be created. Water must be reclaimed. Heat must be controlled. Without these systems, space is instantly fatal. A spacecraft does not protect life by accident. It does so deliberately, constantly, and without pause. Breath is the first problem of space. Oxygen does not linger. It escapes instantly into vacuum. Inside a spacecraft, oxygen must be stored, generated, monitored, and balanced. On long missions, oxygen is produced by splitting water molecules using electricity. This process releases breathable oxygen and hydrogen, which can be reused or vented safely. Carbon dioxide must be removed before it reaches dangerous levels. Chemical scrubbers capture it. Filters trap it. Fans move air continuously so no pocket becomes stagnant. The atmosphere inside a spacecraft is alive with motion, even when the crew is asleep. On Earth, air moves naturally. Warm air rises, cool air falls. In microgravity, air stays exactly where it is. Without circulation, carbon dioxide could build up around a sleeping face. That is why fans never turn off. Air is pushed through ducts, guided across sensors, and returned clean and breathable. The sound of airflow becomes constant background noise. To astronauts, silence is unsettling. Silence means something has failed. Water is too heavy to replace easily. Every drop aboard a spacecraft is used again and again. Moisture from breath, sweat from skin, and even waste is collected. It is filtered, purified, and returned as drinking water. The process is precise. Chemical filters remove contaminants. Bacteria are eliminated. Minerals are balanced. The water astronauts drink today may once have been part of yesterday's breath. In space, waste does not exist. Only resources waiting to be reused. Space itself has no temperature. Heat exists only where matter does. A spacecraft must manage heat carefully, because there is no air outside to carry it away. Electronics generate warmth. Human bodies radiate it. Excess heat must be moved through liquid cooling loops to radiators facing deep space. These radiators glow faintly with infrared energy, shedding warmth silently. Too much heat damages systems. Too little freezes them. The spacecraft constantly negotiates between extremes. Fire behaves strangely in microgravity. Without gravity, flames become spherical, burning evenly in all directions. Smoke does not rise. It spreads. This makes fire especially dangerous. Spacecraft materials are chosen carefully. Wiring is insulated. Surfaces resist ignition. Sensors monitor air for chemical changes. Fire suppression systems stand ready. Astronauts train extensively for fire scenarios. In space, a spark is never just a spark. On Earth, electricity always has somewhere to go. In space, charge can build dangerously. Solar radiation and plasma can leave spacecraft electrically charged. Without proper grounding, this can damage electronics or create sudden discharges. Engineers design systems that allow charge to redistribute safely. Sometimes, spacecraft deliberately release built-up electricity into the surrounding plasma. Even static electricity must be managed with care. In space, nothing is harmless by default. Most spacecraft rely on sunlight. Solar panels unfold like wings, absorbing energy from the sun. That energy is converted, stored, and rationed. Batteries hold power during darkness. Computers manage distribution. Every system competes for electricity. Life support comes first. Science follows. Comfort comes last. Power planning becomes a daily concern. In space, energy is not abundant. It is earned. Spacecraft computers are built with the assumption that something will go wrong. Radiation flips bits. Particles strike circuits. To survive, systems use redundancy. The same calculation may be run 3 times by separate processors. If one result differs, it is ignored. Software is written to recover gracefully, to reboot, to reroute. These computers are slow by Earth standards. But they are reliable. In space, reliability matters more than speed. A door on Earth separates rooms. A door in space separates life from nothing. Every hatch must seal perfectly. Rubber gaskets compress. Metal rings lock. Pressure equalizes slowly. Astronauts inspect doors constantly. They listen. They feel. They check indicators. A failed seal would allow air to escape violently. In space, a door is not convenience. It is trust. Without sunrise and sunset, light becomes a tool. Spacecraft lighting changes color and intensity to simulate day and night. Cool light signals morning. Warm light signals rest. This helps regulate sleep cycles and mental health. Without these cues, the body drifts. Lighting becomes subtle guidance, reminding astronauts that time still exists. Every sound inside a spacecraft means something. Fans hum. Pumps vibrate. Metal clicks as it expands and contracts. Astronauts learn to recognize normal sounds. A new noise stands out immediately. This awareness is not anxiety. It is familiarity. The spacecraft speaks constantly. Those who live inside it learn its language. No system operates alone. Air depends on power. Power depends on cooling. Cooling depends on circulation. A spacecraft is an ecosystem, not a collection of parts. When one system struggles, others adjust. Engineers on Earth monitor constantly. Astronauts perform maintenance daily. The ship is never finished. It is always being sustained. In space, survival is an ongoing process. Most of what keeps astronauts alive cannot be seen. Sensors measure trace gases. Algorithms adjust pressure. Valves open and close silently. Why? Trust is placed in machines that operate continuously, without rest. T. This trust is earned through testing, redundancy, and design. In space, faith is built on engineering. G. Machines keep humans alive in space. But machines are not enough. Humans must live, work, rest, and find meaning inside these artificial worlds. S. In the next part of the archive, we will shift from systems to experience. E. From machinery to perceptio. N. We will explore how space changes memory, emotion, time, and identity. Y. The archive continue. S. On Earth, the body always knows which way is Tao. N. Gravity presses gently but constantly. It orients the senses. It anchors awareness. S. In orbit, that reference disappear. S. There is no up, no down, only position relative to object. S. The brain adapts, but not immediately. Movements feel unfamiliar. Turns must be planned. The body floats where it is left. T. This changes perception at a deep level. L. Without gravity, the mind learns that orientation is not a fact of the universe. It is a habit. T. Most astronauts experience space adaptation syndrome. E. A mild form of motion sickness. The inner ear struggles. Visual cues conflict with balance signal. S. Up becomes down. Forward becomes sideway. S. Nausea passes with time. But during those early days, even simple tasks require focus. S. The mind must build a new model of reality. And it does. S. Quietly, efficiently, without complaint. T. Once adaptation occurs, movement becomes effortless. S. A gentle push sends the body drifting. A fingertip against a wall is enough. This changes how effort is perceived. D. There is no walking, only repositioning. No standing, only anchoring. G. Over time, astronauts report a subtle shift. Thoughts feel lighter. Movements feel intensiona. L. The mind begins to mirror the body. In orbit, even thinking seems to flow. T. There is no lying down in SPAC. E. Sleep happens suspended. Astronauts zip themselves into sleeping bags, attached to walls or ceiling. S. Some sleep vertically, others horizontal. Y. The body does not mind. Once the lights dim and the noise settles into familiar hums, sleep arrive. S. Dreams remain vivid. The mind, it seems, does not require gravity to rest. T. Many astronauts report unusually clear dream. S. Some describe flying, others drifting endlessly. The brain, freed from gravity-based expectation, explores different landscape. S. Memories blend with sensatio. N. The body floats. The mind follow. S. Sleep becomes a place where Earth and space quietly overlap. P. On Earth, time is marked by Chang. E. Sunrise, sunset, shadows lengthening. G. In orbit, the sun rises every 90 minutes. These cycles are ignored. Instead, time is segmented by schedule. E. Wake, work, exercise, sleep. P. Days blur together. Weeks pass gently. Time does not feel fast or slow. W. It feels smooth. H. Without varied scenery, the brain records experience differently. Y. Days resemble each other. This causes memory compressio. N. Weeks may feel like days. Months feel surprisingly brief. F. Astronauts often report that missions feel short in retrospect. T. The mind prioritizes meaning over detail. In space, memory becomes selective. E. Looking down at Earth changes people. E. This experience is known as the overview effect. T. Borders vanish. Cities glow softly at night. Storms swirl without sound. The planet appears whole, fragile. Shay. D. Many astronauts describe a sudden sense of unity. Problems feel smaller. Human divisions feel artificial. L. Earth looks like home, not territory. This perspective often stays for LIF. E. Awe is difficult to describe. It is not excitement, not fear. Ah, it is a quiet recognition of something vast. In orbit, awe becomes frequent. T. Sunsets stretch across continents. Stars appear unmoving and dense. Darkness feels complete. Astronauts often fall silent at window. S. There is nothing to add. D. Being far from Earth does not always mean feeling alone. E. Communication continues. Voices travel. Faces appear on screen. S. Yet there are moments of deep isolation. Earth is visible, but unreachable. E. This paradox creates reflexio. N. Some find peace in it. Others feel its weight. Training prepares astronauts to recognize these feelings without resisting the M. In space, emotion is acknowledged, not suppressed. D. From orbit, Earth looks small. This can trigger a sense of responsibility. To protect it, to return safely, to represent humanity well. Astronauts become observers, caretakers, witnesses. This responsibility is not imposed. It arises naturally. Daily life in space is structured. Tasks are planned to the minute. This predictability calms the mind. Repetition becomes grounding. Work becomes meditation. In the absence of chaos, focus deepens. The mind settles into rhythm. Despite limitations, creativity persists. Astronauts take photographs, write journals, play music. Small acts of expression matter. They maintain identity. They remind the mind that it is more than function. In space, creativity is not indulgence. It is survival. Laughter travels easily in confined spaces. Jokes relieve tension. Playfulness restores balance. Astronauts share humor deliberately. It bonds crews, softens stress. In space, humor is as essential as air. Returning to Earth does not erase the experience. Many astronauts describe lasting change. A deeper appreciation for nature, a reduced interest in trivial conflict, a stronger sense of connection. The mind does not fully return to its previous shape. Space leaves a gentle imprint. The mind adapts to space. It finds balance, meaning, calm. But space is vast beyond orbit. Beyond stations and spacecraft lie destinations that stretch imagination. The Moon, Mars, and farther still. In the next part of the archive, we will drift outward, toward long journeys, deep time, and the future of human presence beyond Earth. The archive continues. That closeness fades. The planet shrinks. Delays grow longer. Silence deepens. Leaving orbit is not just a change in distance. It is a psychological threshold. Once crossed, there is no quick return. The moon is familiar, yet distant. It has no air, no weather, no sound. Footsteps remain for centuries. Returning to the moon is not about nostalgia. It is practice. Practice for isolation, for delayed communication, for operating far from Earth. The moon is close enough to learn from, and far enough to matter. It teaches patience. On the moon, life must be imported. Every breath, every sip of water, every calorie. Habitats must shield from radiation, protect from temperature extremes, maintain pressure without leaks. Outside, the surface is still. No wind erases tracks. No rain smooths scars. The environment does not forgive mistakes. It simply waits. Mars is not difficult because of distance alone. It is difficult because of timing. Launch windows open only every 2 years. Miss one, and the wait begins. Travel takes months. Once arrived, return may be impossible for years. Mars missions are commitments, not visits. They require acceptance of uncertainty. On Earth, help is assumed. In deep space, help is theoretical. Crews must solve problems alone. Equipment must be repaired with what is available. Decisions must be final. This changes how the mind works. Risk is evaluated differently. Caution deepens. Confidence becomes quiet and practical. In deep space, self-reliance is not heroic. It is normal. Earth is wrapped in protection. A magnetic field, a thick atmosphere. Beyond that shield, radiation flows freely. Cosmic rays pass through bodies. Solar storms surge without warning. Shielding helps, but cannot block everything. Exposure accumulates slowly. It does not feel like danger. It feels like nothing. And yet, it matters. On long journeys, time must be managed. Not filled, not rushed. Endless free time can strain the mind as much as stress. Schedules remain important. Rituals become anchors. Days are shaped deliberately. Without structure, time dissolves. Messages to Mars take minutes. Replies take minutes more. Conversation becomes correspondence. Urgency fades. Reflection increases. There is time to think before responding. Silence becomes normal. The mind adjusts to being unheard for a while. On interplanetary journeys, the spacecraft becomes everything. Home, workplace, landscape. There are no new rooms, no new horizons. Familiarity deepens. The ship becomes known intimately. Every sound, every vibration. In time, the crew does not feel inside the ship. They feel like part of it. Distance in space is not dramatic. There is no sensation of speed. Stars do not streak past. Movement is inferred through instruments. Days pass. Numbers change. Arrival is not felt until it happens. The journey is mostly waiting. When a spacecraft reaches another world, there is no celebration. No fanfare. Systems check. Data confirms. Landing procedures begin. Arrival feels procedural. The significance arrives later, quietly. Mars' gravity is weaker than Earth's. Movements feel lighter, balance feels uncertain. The body adjusts again. Muscles relearn effort, bones relearn load. Gravity, even when reduced, shapes experience. On Mars, habitats remain sealed. Outside air is unbreathable. Pressure is deadly. Life exists inside shells. This separation changes perception. The outside becomes something to visit, not inhabit. Inside becomes precious. Earth appears as a bright star in the Martian sky. Small, pale. This distance reshapes identity. Home becomes an idea, not a place. Connection persists, but differently. Robots are efficient. Machines are tireless. And yet, humans continue to plan journeys outward. Not because it is easy, not because it is safe, but because presence matters. Observation changes when someone is there. Meaning changes. Humans have always moved outward. Across continents, across oceans. Space is not different in motive, only in scale. The impulse remains the same. To see, to understand, to be present. Leaving Mars is not the end. The return carries its own weight. Earth grows larger. Communication quickens. Gravity waits. The body prepares again. After deep space, Earth feels dense. Loud, heavy, gravity presses. The sky feels close. This adjustment takes time. Space does not erase humanity. It reveals it. Habits, strengths, vulnerabilities. Far from Earth, humans remain human. Beyond planets, beyond missions, beyond return, space continues. Vast, silent, unchanged. In the final part of this archive, we will step back, not toward a destination, but toward perspective. Toward the quiet truths that space reflects back to us. The archive approaches its closing. Most of space is nothing. Between stars, there are vast regions where atoms are so sparse they rarely meet. Even within galaxies, matter is scattered thinly. What we see in images, nebulae, stars, glowing clouds, are the exceptions. The universe is defined not by what exists, but by the spaces between. Emptiness is the dominant state. When you look at the stars, you are looking backward. Some light left its source years ago, centuries ago, millions of years ago. Some stars you see no longer exist. Their light continues traveling, long after the source has changed. In space, the present is layered with the past. Space is dark not because there is no light, but because light rarely meets anything to reflect from. Photons pass endlessly, unnoticed. Darkness is not emptiness. It is distance. In space, everything moves. Galaxies drift. Stars orbit. Planets fall endlessly. Yet there is no feeling of motion. No wind. No vibration. Movement exists without experience. Speed becomes abstract. Gravity is patient. It does not announce itself. It curves paths, binds systems, holds structures together over billions of years. Even the largest objects respond to invisible pull. Nothing escapes gravity completely. Not even light. Time is not uniform. Clocks tick differently in strong gravity. At high speed, the difference is small, but measurable. Time bends slightly, constantly. The universe does not share one clock. Stars feel permanent. They are not. They are processes, burning fuel until balance ends. Some die quietly, others violently. All eventually fade. Even the sky is temporary. Planets can lose atmospheres. Oceans can vanish. Surfaces can freeze or burn. Habitability is delicate. Earth remains stable through a rare balance of distance, mass, and history. It is not guaranteed elsewhere. Silence in space is not emptiness of meaning. It is neutrality. Space does not judge. It does not respond. Loneliness arises from expectation. The universe simply exists. Numbers lose meaning. Millions, billions, trillions. Distances become symbolic. The mind adapts by letting go. Understanding becomes approximate. And that is enough. We do not yet know. The universe is large, old, capable. Life may be common but distant, or rare and brief. Silence does not answer. We are not observers from outside. Every atom in the body was forged in stars. Carbon, oxygen, iron. We are rearranged stardust, thinking about itself. Going into space is not conquering. It is paying attention, measuring, observing, recording, listening to what exists without trying to change it. Tools follow questions. Telescopes, probes, sensors. Each answers one question and raises others. The archive grows slowly. The universe has no edge, no center. Every point appears central from where it stands. Perspective creates meaning. Space does not provide purpose. It provides scale. Meaning emerges from how we respond. From wonder, from care, from restraint. From space, Earth is not dramatic. It is subtle. Thin air, liquid water, moderate temperatures. Life clings quietly. Those who see Earth from afar often describe the same feeling. Connection, fragility, responsibility. The feeling does not fade quickly. After looking outward, attention returns. To small things, breath, gravity, sound, the ordinary regains weight. The universe is not busy. Most things are stable for long periods. Rest is common. Change is slow. Cycles exist everywhere. Rotation, orbit, cooling. Rest follows activity. Even stars pulse. Knowledge accumulates. Quietly, without urgency. Each mission adds a fragment. Each observer adds context. Some questions remain unanswered. This is acceptable. Silence is part of understanding. In cosmic time, human history is brief. In human time, a single life is full. Scale does not diminish meaning. You are here, on a moving planet, orbiting a star, inside a vast structure, and for now, that is enough. This record does not conclude. It pauses. Space continues, time continues, and so do you.